What if I told you that every night, while you're deep in sleep, your brain runs something that looks a lot like a dishwasher cycle? Your brain cells actually shrink by around 60%, and a wave of cerebrospinal fluid surges through the spaces between them, rinsing out the metabolic gunk that built up during the day, including the very proteins that get tangled up in Alzheimer's disease. And here's the part that should grab you. Most adults are barely getting enough of the specific sleep stage that powers this brain rinse. The good news, of all the sleep stages, this one, deep sleep, might be the most fixable. So today, let's walk through what the research actually says about a 30-day approach to deepening your sleep, what's realistic, what's hype, and the simple levers that show up again and again in the data. Hey everyone, and welcome back. Today we're talking about deep sleep, specifically the stage scientists call N3 or slow-wave sleep. This is the heavy, dreamless sleep that hits hardest in the first few hours after you drift off, and it's the stage where your brain does its most important housekeeping. We're going to cover why deep sleep matters so much for your long-term brain health, what a realistic 30-day plan to boost it looks like, and the common mistakes that quietly steal it from you, including one that's probably in your fridge right now. I want to be upfront. You may have seen claims floating around that you can add a full 90 minutes of deep sleep in a month. For most people, that's wildly optimistic. The studies suggest a well-stacked protocol can realistically add around 20 to 40 minutes, and honestly, that's still a huge deal for your brain. Let's start with the mechanism because it's genuinely fascinating. In 2013, a team led by Maiken Nedergaard at the University of Rochester published a landmark paper in Science describing what they called the glymphatic system. Think of it as your brain's plumbing, a network of channels around blood vessels that pumps cerebrospinal fluid through brain tissue to flush out waste. In their experiments on mice, glymphatic clearance of beta-amyloid, one of the proteins implicated in Alzheimer's, was about twice as fast during sleep compared to wakefulness. Then in 2018, Shakri Kajori and colleagues at the NIH published a study in PNAS showing that just one night of sleep deprivation in healthy adults raised beta-amyloid in the hippocampus and thalamus by a measurable amount, with cerebrospinal fluid amyloid up roughly 10%. And a separate study in the journal Brain found that selectively disrupting slow-wave sleep, without reducing total sleep time, was enough to bump amyloid up the next morning. So it's specifically deep sleep doing a lot of this work. Now, I want to be careful here. A 2025 paper sparked real debate about whether sleep is truly the dominant clearance window, or whether wakeful clearance does more than we thought. The link between deep sleep and brain waste clearance is real, but the story isn't as clean as the headlines make it sound. What we can say confidently, improving deep sleep is associated with better cognitive outcomes and lower amyloid burden. What we can't say, that any 30-day protocol reverses or prevents Alzheimer's. Anyone selling you that is overpromising. Okay, let's get practical. Week 1 is about two of the most powerful and most ignored levers, temperature and consistency. Your brain initiates deep sleep partly in response to a drop in core body temperature. So the first move is cooling your bedroom. The sweet spot in the research sits between about 60 and 67 degrees Fahrenheit or 15 to 19 Celsius, cooler than you'd think. The second move sounds paradoxical. Take a hot bath or shower 60 to 90 minutes before bed. A 2019 meta-analysis by Haghaeg and colleagues in Sleep Medicine Reviews found that warm bathing in that window increased slow-wave sleep by 15 to 36% and shortened the time it took to fall asleep by about 10 minutes. Why? The heat dilates your blood vessels, and once you step out, your core temperature drops faster than it otherwise would, and that drop is the signal your brain is waiting for. The third move in week 1 is consistency. Same bedtime, same wake time within a 30-minute window, 7 days a week. Yes, weekends too. Deep sleep is concentrated in the first 3 to 4 hours after sleep onset, so sleeping in on Saturdays mostly adds REM, not N3. Bedtime regularity is the lever that matters most. Week 2 is about subtraction. There are two everyday substances that quietly demolish deep sleep, and most people underestimate both. First, caffeine. A 2013 study in the Journal of Clinical Sleep Medicine by Drake and colleagues had participants take 400 milligrams of caffeine, roughly a large coffee, at various times. Even when consumed 6 hours before bed, it cut total sleep by about an hour and shaved measurable minutes off N3. Caffeine has a half-life of around 5 to 6 hours, so that 3 p.m. cup is still very much in your system at bedtime. The protocol-friendly move, cap caffeine at around 1 p.m. Second, alcohol. This one's sneaky. A nightcap actually does increase deep sleep in the first half of the night. That's why people feel like it helps them sleep. But in the second half, you get fragmentation, REM rebound, and middle-of-the-night wake-ups. Net deep sleep quality drops. If you want to test this, take 2 weeks off alcohol and look at your wearable data. People are often shocked. Also in week 2, finish eating 2 to 3 hours before bed. Late, heavy meals raise core body temperature and pull blood toward digestion. Both work against the temperature drop your brain needs. Week 3, we add the active ingredients. First, daytime exercise. A 2025 BMC Geriatrics review on exercise and sleep quality found that both moderate aerobic work and resistance training improve sleep architecture, with the cleanest effects when training wraps up at least 3 hours before bed. Aim for 30 minutes of moderate aerobic exercise most days, or 2 to 3 resistance sessions a week. The mechanism is partly about building sleep pressure and partly about regulating core temperature rhythms. Second, morning light. 10 to 20 minutes of bright outdoor light within 30 minutes of waking anchors your circadian rhythm, which makes melatonin release later that evening cleaner and on time. This is one of the highest leverage, lowest effort moves in sleep science. Third, and this one's a fun one, try sleeping on your side. A 2015 rodent MRI study by Lee and Benveniste in the Journal of Neuroscience found that the lateral or side position was the most efficient posture for glymphatic fluid exchange, more so than sleeping on your back or stomach. It's animal data, so don't oversell it, but it costs nothing to try. Week 4 is the optional stack, the stuff that might help on top of a solid foundation. Magnesium bisglycinate at 200 to 300 milligrams, about an hour before bed, has modest evidence. A 2025 randomized trial in Nature and Science of Sleep with 155 adults showed a small improvement in insomnia severity, with the biggest benefit in people with low baseline magnesium intake. If you have kidney disease or take certain antibiotics, blood pressure meds, or proton pump inhibitors, check with your doctor first. Now let's talk about melatonin, because there's a real misconception here. Melatonin isn't a sedative, it's a circadian timing signal. And the high doses you see at the drugstore, 5 or 10 milligrams, may actually reduce slow-wave sleep. If you use it at all, the research points toward low doses of 0.3 to 1 milligram, used mainly for jet lag or shift work, not as a nightly sleep deepener. One last note that goes beyond the protocol. If you snore loudly with pauses, gasp awake, or feel exhausted no matter how long you sleep, please get screened for sleep apnea. No behavioral protocol substitutes for that diagnosis, so here's the realistic picture. Over 30 days, by cooling your room, warm bathing before bed, locking your schedule, cutting late caffeine and evening alcohol, exercising during the day, getting morning light, and considering side sleeping, most people can plausibly add somewhere in the range of 20 to 40 minutes of deep sleep per night. That's not a miracle, but it's meaningful. It's more the brain stage where memory consolidates, hormones regulate, and that glymphatic rinse runs strongest. If you want to track it, a wearable like an Oura Ring, Whoop, or Apple Watch is useful, not for the exact numbers, which aren't perfectly accurate, but for trends. Pick 3 or 4 of these levers, run them for a month, and watch your own data. If you take one thing from this video, let it be this: deep sleep isn't fixed. It's one of the most modifiable parts of your sleep architecture, and the levers are mostly free: temperature, timing, light, movement, and what you don't put into your body in the evening. Your brain has a built-in maintenance system, and giving it the conditions to run well is one of the highest return things you can do for your long-term cognition. Thanks so much for watching, take care of yourselves, and I'll see you in the next one.